Hello, my name is Jamie, and today we're going to be trying something different. So, I wrote code for making this walkway, and as I did, I recorded it. So, what I'm going to be doing is basically playing the live coding session and then running a voiceover over it, giving notes as we go about what's going on. So, we'll try it, see what happens. Hopefully, you like it, and hopefully, you learn something about CadQuery. So, first bit is I'm going to open up CQ Editor. This is leftover code from my last session. We're going to start a new file. Now that the new file is created, I'm going to pull in boilerplate lifecycle code. This is my boilerplate. This code includes a make lifecycle and a build lifecycle. Here, BP is short for blueprint, which is where we're going to set up our make definition parameters. We're assigning the result of our build, and then we're going to show the resulting shape from the build lifecycle. And of course, nothing works as planned, so we got to fix it. First bit is we need to assign our generated walkway, our outline, to self.walkway. And then on the build, we need to actually return back the resulting shape. So here we're making a CQ work plane, which is bog standard for CadQuery. Putting it on the XY axes, thinking some about what we want to do. And then adding our self.walkway. Eventually, we'll get there. Finally, we need to return back our scene object. So scene is where we're going to store all of our stuff, all the generated files. It's basically the composition layer. And now we're going to start modifying some of the parameters to see if changes take effect. Yes. So now we can set the width of the walkway, or the width of the outline at the moment. It's a very basic shape. And we'll union it to the scene object. The first piece I'm going to start defining are the cutout slots. I forgot, so I need to reference documentation for how to make a 2D slot. And in particular, where I have that is on my GitHub gist. So here I'm floundering about to find the gist. This is the CadQuery primitive shape documentation that I wrote up. I'll reference that in the description, the video description. So here's the code, outcome of what I'm looking for. And this will be the baseline for the cutout slots on the walkway. Right now I'm filling out the make slots method. Where we had our union and we're showing the body of the walkway, we're just going to show the individual slot. There's the 2D cutout. We'll start signing at our parameters that we have defined. And slot underscore length will be derived off the size of the walkway itself. This output was not what I was anticipating, so I'm going to look up the documentation on CadQuery. And luckily in the gist I have links directly to the code, the definition code in CadQuery documentation. Now what I'm trying to glean is the order of the parameters. Still not doing what I'm expected, so we're going to resort to throwing in a log to see what the slot underscore length value is coming out to. I'm getting the inset cut here because the slot underscore length value is negative, so we've got to resolve that. That's more better. Now we're just doing some code formatting to make it more readable, and we're going to extrude it in order to add the third dimension. Now we'll bring back our walkway body. We need to rotate the slot, and looks like I need to center it. So first bit is center the height. That centers the height. Because this isn't really length, we're going to rename the attribute to width because it's going along the y-axis. Now I need to start fixing the error I introduced. That's actually a cool design that might be useful elsewhere. All right, so now hopefully the attributes should make more sense on the in reference to where they're being used. Now we're going to apply the rotation, and we have our first cutout slot. And then slot padding is the distance coming off of the padding coming off the top of the walkway. So by changing this distance, making it greater or lesser, we'll just find the overall, uh, is it the width? I forget. Yeah, the overall generated width of the slot. Now I'm importing in Cadqueryhelper series, so we're going to make a line of these cutout slots. And I need to look up the documentation for how to make a series. So I wrote it, but I don't always remember what I wrote. So I need to define the shape, the overall size, and then the offsets are what define how the shape repeats. And here I'm just doing a rough test. We got 5 repetitions of the object. The offset is too high. Here I'm realizing that the size of the offset is really just the distance between the objects is what I'm actually setting here. So having to define the slot dot length as a length offset is too heavy. And so by setting it to -3 off the slot length, I'm basically zeroing it out. So if I just set slot length offset equal to 0, there we get our repetition, and all I need to do now is define the distance between each repetition or iteration. Adding additional parameters in order to deal with spacing out the cutout slots. The margin comes off of the overall for the spacing at the ends. Yeah, we're rechanging that. Okay, that'll come later. Now organizing the code so it's more readable. Testing to see what different values, whether that affects the sizing. Now we're going to dynamically generate the size attribute. So at the moment, it's a hard-coded size of 5, and we're going to generate how many cutout slots we should have based on the length of the walkway. Here I'm adding a debug statement to make sure that the size is coming up with something within reason. We're also going to do a math floor so we don't get a float return. So when we do the division, we're not getting a float. We just get a straight integer. In this case, it returned 50, which is probably not what I was anticipating. So now we're going to calculate out what we're expecting to return. Now is my oh duh moment. That's how we're resolving out to our 50. So because it has a length of 150, so we need to account for our offset padding. That puts the count at 21, which seems far more reasonable. And there's our cutout slots, at least in series. We haven't actually cut them out yet. So now, when we change the width of the blueprint, the number of slots should adjust accordingly. Now I'm going to adjust for what I was alluding to earlier, which is the end cap margins. And that's the amount of padding at the end where where I want room for wiggle, right? I don't necessarily want the slots to butt up all the way to the ends of the walkway. And that should do it. So based on what we're basically doing is we're finagling uh, the size of the walkway based on those by removing off the end cap margin. So where we have a size of 150, we'll remove off, in this case, 10, making it 130. So when we generate the size of the slots, it'll be based off of whatever the number is. Yeah. So that's with the end cap margin at 0, go butts right up. And so I'm going too fast for what I can keep up with here. The gist is we take our length and then we minus off the slot end margin times 2. So if it's at 5, we times that by 2, making it 10. So instead of 75, it's now 65 for where we generate the size of our slots. And we're taking full advantage that the return of the series is always centered on the X, Y, and Z axis. Now we change it from an add to a cut, and finally we have our cutout slots. Next bit I'm going to start defining are the connecting tabs. And it helps if I can spell. So first bit is define your parameters for the feature you want to add. Next is define where the shape is going to be assigned to. And then for this one, I'm going to introduce the pattern of adding the renderers so that features can be toggled on and off. And so I'm going to go on a quick diversion in order to test out the slot renderer. So it's just a feature flag. All it does is say, oh, I should render this or not. So we have to take the generation of these different shapes. So in this case, to make slots, we're going to add an if check. And so we're saying here if render slots is true, and we also got a return back from our scene for the number of slots, then we'll start doing the cut operation. And otherwise, if it's false, we won't render it at all. And so what that does is that's very actually helpful in development. So if you want to just test something in isolation, being able to turn on and off different features of the model is immensely helpful. and that'll set up the overall pattern for how new features are added. You generate the parameters, you create the render feature, and then all of the makes and all of the builds are prefaced by the render flag. So here we're making our stub make tabs method. First bit is, make an individual element as proof of concept, then create the duplicate elements and basically align accordingly to the body of the model. So here we turn off the rendering of our slots, we turned off the rendering of our body by removing that union line, and then we're going to add our individual tab to the scene. And of course, something went awry. Need to add a self. There we go. There's our individual tab in isolation of the rest of the walkway. Now I can pull it back in and see this is where I would have gotten thrown because it's in the very center of the walkway. So we need to align it. So we'll do that by throwing in a translate. And the first place it looks like I'm going to start is along the x-axis. All right, that put at the end of the x-axis, although I tend to prefer when I'm working with this having it aligned along the negative x as opposed to the positive x. And because that code's starting to get a mess, we'll create a separate attribute to store the x translate. Now we'll define, because we've already started the pattern of making translate variables, we'll make the y translate. Of course, that's up too high. Okay. So now we have the start of our tab at the end of the walkway, which is just the connection bit. So we'll start our work plane for where we'll store the two tabs. And effectively, all I'm going to do is create an empty work plane, assign add the tab, in this case, union the tab again, but rotate it. And this works because we've already translated it away from the center point. So the rotation will happen from the center point outward. And so when we apply a rotation, uh, it'll maintain its spatial relationship to the center point. There we go. So now we have two tabs. And so we'll union our tabs. Of course, something went awry. And for the astute reader, you'll see that something doesn't look quite right. So I'm basically saying scene.union, but I don't actually assign it back to the scene variable. Right now, what's basically doing is a raw show object output. And so it's not quite right at the moment. So we're going to go through a little bit of debugging while I try to figure out what I broke. And lo and behold, it works magically. Yeah, there we go. And the importance of using union is so it makes one individual shape as opposed to a collection of shapes. So right there are three disparate shapes. If I use union, it'll join those together to make one shape, which is what I'm looking for. It makes further operations easier if you use unions early when doing the composition layer. There we go. So now we have our render slots and our render tab all being applied to the walkway. Now we're going to start defining chamfer, which is going to be basically cutouts from the slots. Change that to an add. I'm going to simplify my code down so it's just dealing with a tab while I try to apply this chamfer because I need to figure out the faces in which to apply it. So simplifying back down to just one tab, we're going to add a chamfer operation, make it very small so I can see it. And what I'm trying to do is describe the selection language for what edges I want to chamfer. So that's along the x-axis, x positive. Now we're going to x minus. Now we're selecting the edges, and that gets us our corner bits. And now I can say self-tab chamfer. And of course it broke because 5 was too high. So the realization here is that the chamfer can't be, it can't equal, yeah, the tab length. It has to be less than whatever the tab length is. All right, so now we have our translate applied. Now we have our rotation applied with the two tabs, and we need to return back our body. And of course, we're doing an add, so that needs to be union. And there we go. And then I'm basically doing some testing to make sure I didn't break anything. Here I'm having a moment of zen when I try to figure out what I want to do next. So we're going to start defining the rail parameters. First with the rail render flag. So start adding in our stub make rails code. Add the placeholder for where the rails are going to be, the rail shapes are going to be added to. And then to start defining how the rail shapes will be added to the body of the walkway. Fair enough. So we're going to follow the same pattern for making the tabs. So we're going to define our individual rail. That's going to be a CQ work plane. Probably start with just a box. So far, right? We're going to define it based on the length of the walkway, the rail width, and then the rail height. Then we'll say self.rails equals rail, and of course something went awry because we forgot our self attribute. So now things get a little hairy because I want to scale this in reference to the size of a miniature. So I'm torn on what the correct starting size should be for the railing. So we're going to make a mini proxy, which is effectively just a stand-in for a Wargaming mini. And to do that, all I'm going to do is basically define a cylinder. So we'll make the gist of a cylinder. I always forget the cylinder parameter order, which one's the diameter and which one's the height. That one's not intuitive to me at all. So effectively, I'm looking for something with a diameter of 25 and then a height of 32 millimeters. That looks about right. So we're going to define the width of our walkway to be more representative of the miniature. Start scaling it. And we're going to move the mini so it's positioned not on the origin point. And of course I forgot my times. So my flip bit didn't work. And here all I'm doing is just a translation to align the proxy miniature plus the tab length. And remember, BP here is short for blueprint. So we're just getting the parameter for tab length off the blueprint. Now, regardless of whatever I set the length of the walkway to, the positioning of the miniature adjusts for it. Clean up our code a bit. Try to make it more readable. We'll see. And now we need to adjust our Z translate. Okay, so that's roughly, I think, where it needs to be. Now we're trying to place the miniature on the platform so we can see in relation. And all of this is to try to figure out how tall I want the rails. So now we're going to translate the rail, position it. Okay. All right, so that moved along the y-axis. Now we'll set up the height translate. And I'm just blatantly copying code. And I need to apply it to the translate itself. further adjustments to the Y translate. Now it's aligned to the model. And what I don't like here is that the slot padding cuts into where the railing is. So now to effectively align the slots, I need to take into account the rail width. So basically looking at the affected parameters and where we make our slots, if we take into account the width of the railing, then we can align the slot width according to that. So now if I set to 0, instead of cutting underneath the railing, no, maybe not. Yeah, okay. So I have to set in negative margins to start cutting underneath the railing with this change. And as long as I have a positive integer, it'll take into account the width of the rail and the padding. And poorly spelled, but slots now take rail width into consideration. So we'll adjust our height, test that out, see if that works. That's aligning where I want it to effectively. So now we're going to unscrupulously copy our um, code for making multiple tabs and do the same thing for making multiple rails. There we go. And now we have 2 rails. Because of the chamfer, the tab length broke. I'm trying to get an overall outline to see if I'm happy with it. So next we're moving on to defining a chamfer for the walkway. So overall, the outline, the silhouette of the walkway, I'm trying to adjust at the moment. So I'm thinking about basically applying a chamfer to the body of the walkway. So we have the attribute defined in the blueprint. We're going to define it in the actual class. And then when we make the body itself, we're going to apply a chamfer operation. And so this is going to get a little bit involved, whereas we're basically going to say, well, if the chamfer actually has a value, then we'll apply it. Otherwise, we'll just leave the body of the walkway alone. And here I'm trying to discern what edges I want to apply the chamfer on. Instinctively, I always go through a troubleshooting phase when writing chamfers or fillets, figuring out how I want it applied. So we're going to simplify out the design. This is where the renders come into play. Start turning off features. And now we just have the base walkway body. And for the astute watchers here, you'll see I already introduced a bug. Yeah, that's going to break. Now let's see how long it takes me to figure out why. Yeah, that might do it. Okay. Why is it breaking? Now we're fuddling about. Let's just copy code from elsewhere. We'll cheat. Does that work? No, that didn't work. Ah, yeah, that might do it. Okay. So we had an extraneous dot. Now, as far as the face is, I really want to apply it on the bottom of the body. All right, so that's our negative z-axis. So if we hit our negative z-axis, and we can apply it to y, which is the edge. So we're going to apply it to the y edge. I think I already did that, but that's all right. What does that do? That does both sides. Yeah. So really what I want is I want to apply the chamfer just on the x-axis, um, the edges following the x-axis. So that was doing not x, which applied it to the y-axis. So if I say not y, that applies it to the x-axis. And that's getting me a better, an improved silhouette, a silhouette I appreciate more. And then the next bit I don't like is that if we apply a chamfer that's too great, the error message we get is a little bit obtuse. So we're basically checking that our walkway chamfer isn't greater than the height of the body of the walkway. So we're saying as long as walkway chamfer is less than, and then we're going to throw in an else clause. And in this case, if we get a walkway chamfer that's not less than the height of the body, we're basically going to throw a custom exception. We're going to kill the run. And I like this pattern. So this was a good walk away step, a good lessons learned from this code run. Is I like catching this error here custom as opposed to running a BP render error or a brep render error. So now we're checking the conditions under which we can throw this error, see if it goes correctly. Basically doing fuzzing edge case testing right now. So this is just up to the line, and now it errors. And I'm seeing if it throws the custom error. And we're adjusting the stack trace, the exception thrown. And the point is to give better information uh, to the reader effectively, to the implementer, and fail fast. So now we're adding features back in. Now we'll start adding a feature for chamfering the rail itself. And we're simplifying down what we're looking at for the feature set. So instead of showing both rails, we're showing one rail. And we're going to apply that same pattern we just used for doing the body chamfer to the rail chamfer. So first bit is we're going to chamfer our rail, and we're going to do this whole exception stack trace test. And of course, this is breaking right now because my rail chamfer is way too high for the body of the rail. In a lot of cases, you'll see I catch that early. Like if you're going to do a chamfer across the whole body of an object, you want to set it fairly low. And so now we need to start defining the face and edges in which we want to apply the chamfer operation. And again, simplify down. We're going to grab the code that we used successfully earlier, apply it here. So we're going to grab the faces, we're going to grab a face, we're going to grab the edges, and then try to apply it. And now it's just a matter of troubleshooting. Again, every time I do this, um, it's always a troubleshooting, see what you get. All right, so that applies it to at least the vicinity. That's the face I want is the Z face. And then we're going to say, use the trick that we used for the body before. In this case, we're saying not Y, which will apply it to the X-axis. Now we're going to say not X. And that gets it roughly where I want it. So now I can set the chamfer higher. Bam. And now we'll start duplicating the code effort, the exception use case. Going to the exception code, reword it a little bit. And if I was to go back through and refactor this code, I would apply the same use case pattern to how the tab chamfer is applied as well. Looks like my indentation's wrong. Yep. That was it. Now we'll take it down to our blueprint, start adding different attributes, and see where we can break the rail chamfer. And there's our custom error, and there's a successful run. Now we'll start returning back our features. We need to reapply our translate and then reapply our change our return. So now we have both rails with a chamfer applied. Handy dandy, spiffy. Now onto the next feature is we'll start defining out the rail slots. Well, the placeholder for the rail slots. Based on a feature flag is whether we'll render the slots or not. And then we'll make a stub uh, make method. So let's test something. While I was coming up with adding the slots, I had an epiphany. There we go. So I'm trying to determine how I want to best show the rail slot in relation to the rails. So we'll turn off our body. We'll turn off our other feature flags. And probably turn off the display of multiple rails in the translate. So basically simplify down, have a separation of concerns. Okay, so now we're just showing our mini proxy, and we'll start defining off the make rail slot method, hopefully. So first to find out if our parameters for it. Start defining the work plane and make a box. Of course, I've got so many parameters, I'm starting to forget the names of these things. So the size of the rail slot is in relation to whatever the rail is. So based on the rail width and the rail height, that defines the rail slot. Yeah. So we need to define the padding off the top. And for some reason, it doesn't look like my rail slot length took. Testing if the naming was correct. Maybe I misspelled it, fat fingered it. Oh, so I apply it. Okay, so that's a good lessons learned. So I set those parameters after the BP make. The BP make is when the build happens, so setting the parameters after the BP make is pointless. It's not going to help you. The build's already happened after the BP make. Yeah, okay. So this is going to be the padding off the top. Yep, define the parameter so it's more distinct. Of course, I'm just defining against the blueprint. I need to actually add a parameter to the class. And so when we make our height, we need to take into account this rail slot padding top and apply it. And now we need to translate it. So I want it aligned to the bottom of the rail for this cutout. Yeah, that should take care of my error. And then that should be aligned to the bottom now. Oh, okay. So one translate for the yeah, hold on a moment. So one translate for the railing and then one translate for the um, rail slot in relation to the body of the railing. So when we translate the railing itself, we also have to translate the rail slot to follow suit. Now we'll make our series. And the size code we're just going to grab from the walkway. So we'll grab all of that effectively. And just adjust. So all of the parameters I have for the floor slots, I'm basically going to have matching for the rail. And so we're going to note what our new parameters should be. And then make them after the fact. And here we're setting the shape. We need to set the offset. Which axes the um, repetition will occur on for the series. And then we need to define our size. Do some formatting, add our size attribute. And then for our new parameters, we need to define those in the body of the class. Go down to the blueprint, add them down here. So we can start adjusting them and seeing if it works. And I already introduced a bug. So here you see I have rail slots end margin set to 2, and then the length offset set to 10. That's going to be a problem. Return back. Farther distance than I would have liked. So here's my aha moment where we basically flip these guys. We'll do the same down the blueprint. And there we go. And so this is a mixture of testing and design, right? Trying to see what I like best for kind of the defaults, and then testing edge cases to see if it breaks. So now we need to apply the cut to both rails. Right now it's being applied to one. And so here we're going to make an empty work plane, union in the rail slots, and then add the rail slots again, but apply a rotation to it. Return that out. Bam. Start turning back on our features. Bring back the walkway body. There we go. So now we have our rails with the slot cutouts, with a walkway, with the slot cutouts, and then the tabs, and various body chamfers. So now we're going to get extra tricky. Effectively, I want the ability to change out the shape of the rail slots. This is kind of fluff, effectively. So I'm going to go, I think, to Cadqueryhelper is where I'm going to end up. Yeah, I'm going to end up back at Cadqueryhelper, which is a library that I wrote, and we'll have stuff like the arch shapes and effectively a way to swap out. So right now it's just using the slots for the rails are just made up of boxes, and so I want to basically be able to apply different shapes. And ideally, probably get to a point eventually where the shapes can be basically defined by the developer. But at the moment, it'll be a hard set list of shapes that are supported. So I'm basically singling out that I'm going to use the arch pointed and the arch coming out of the CadQueryhelper shapes, and those will be supported by the walkway. And I'm trying to see what parameters I need in order to define it and kind of working out implementation. So now we're adding our new parameter, which is going to be a text field, basically saying, okay, what kind of rail slot type would you like? And so if the type is a box, then what we have existing code, so basically just code for what you already have, right? Here I'm saying it should be lowercase because I forgot how to do lower cases in Python. Very shortly, I'm going to do a lookup for how to do lower cases. Said screw it. What's the code for lower? It's just dot lower. Okay, so we'll just do that. So whatever string you pass in for a type, we're going to lowercase it. And then do the comparator against the cleaned up string. And then else, if it's an unrecognized type, we're going to throw an exception, killing the run with a custom error. As a general rule, I don't like having open if statements that don't have an else. So if I have like if, elif, if there's no trailing else statement, that's generally like a code smell. That's a point where I'm going to add an exception to basically fail the code out. So here we're going to the blueprint, defining, making sure this works. We're going to define a type that's incorrect, making sure that exception worked as expected. Now we can start adding our alternate case. There's different ways I would work this if we had more than like 3 types. In this case, because there's so few types, I'm using an if-elif. Otherwise, what I would use is effectively create a dictionary of types assigned to methods, and then have the sub methods be called here, right? So I basically say if type is in my dictionary of methods, then run this given method. This is the pattern I prefer. Basically, make it a map operation. But because there's so few of these, I just didn't opt for that. So we're just kind of inlining this code. And it's probably simpler for the first time viewer to go with this pattern, right? Because eventually what would end up happening is, well, the developer could submit in their own callback, their own arch type. And then whatever the return from that is what we'd use for the cutout shape. So now we're just slotting in, we're just filling out the parameters with the parameters we have available. And the parameter I'm missing is that inner height. Okay, so did anything change? Sure doesn't look it. It's because of that box. And what else didn't work? Ah, on the blueprint we didn't change it. That looks a bit different. We need to change that inner height. So here I'm describing a full sentence of a parameter to define for the inner height. Put it on our blueprint. Start making a list of accepted parameters. And this is just code comment. That's just informational. So then we'll add our third type, which is going to be arch round. That's going to be fairly straightforward to add. I don't need inner height for arch round. Verify what the parameters are. And on our blueprint, should be able to change it to arch round. And there we go. Cool. Neat. So now we've changed it to box, arch pointed. and arch round. And that'll be the initial set of supported rail slot types. So now I'm playing around. So where it's going to come down to is I'm going to make two different variants of the bridge, play around with parameters. Or, yeah, we're going to make two different variants of the model. Let's kind of see how that works out. So I'm testing out features and seeing what I like. So I'm testing what the rails would look like if it was more like a bridge, right? Yeah, so here I'm trying to think how I best want to make the second bridge, right? Do I just want to start over from scratch? In this case, I'm doing something a little bit odder. So because all it is it's a factory for making walkways when you define the blueprint. Um, anytime you call bp.build, you're effectively generating off a one-time shape. So what you can do is effectively take your blueprint, call build, do a show object on it, change your blueprint, call build again and assign it to a different variable, and now you have two different instances. So now we have two bridges, two distinct bridges. And as soon as we start changing parameters, um, well, you'll see we'll have two completely separate instances, effectively, all derived off of the same blueprint with modifications. So here I'm basically calling the blueprint again, start modifying parameters, and of course having an error. Probably having to do with the chamfer or someplace. There we go. So we have one railing that's going to be a bridge, and then another one that's just going to be a walkway. And we'll start modifying parameters for it. So it's kind of a unique feature of using these two lifecycle events, the make and build events, because effectively you can take the same factory class, start changing its definition, and then generating off new instances off of that definition change. Now, whether that pattern truly works well in practice, it's hard for me to say. Because effectively, what you're relying on is Bridge 2 is relying on cascading attributes from Bridge 1, right? So that's not ideal. So, for the sake of this code session, these were the two variant bridges that I effectively settled out on. All right. So, these are what the two walkways look like in the real. So, this one is the 225 millimeter, and this one is the 150 millimeter. And somewhere I have a figure to show in relation to it. So this is this with the Necron, old metal Necron, and it works well if I have one. It works well with the 40 millimeter bases. Yeah, this guy right here. So here's a guy, a large base model, right? So here he fits on the regular walkway. Both miniatures fit well, that kind of stuff. And the idea with the tabs is that if you have basically two disparate shapes, that it should just connect up with enough. Of course, I need a flat surface. That would help. Hang on a moment. See if I can get this a little bit better. Maybe something like that, right? And this should be fairly stable. So that's the sake of the tabs. When this is printed, I end up using um, overhangs effectively. Um, not overhangs, support materials. I end up making printed supports. Uh, that's it. Cool. All right. So if you made it this far, I appreciate it. Thank you. And yeah, have fun programming in CadQuery.